Hello children, this is Edison. In this video we are going to discuss about the chapter Integrals part 7. In this part we'll be discussing the topic definite integrals. We have studied the indefinite integral in the previous videos. That means actually integral f of x dx is nothing but we wrote that it is f of x plus c. So this is actually indefinite integral. Here we will be getting many different answers, children. Family of curves we will be getting. Yes, we will get a family of curves. Okay, yeah. So now the definite integral means it will be having the limit like this, a to b f of x dx. Okay, now see children, we are getting this actually nothing but a curve. Family of curves we will be getting. So now I just draw one curve only. So if you integrate the function, okay, we get the family of curves. Okay, yes. So that is what a indefinite integral. But here in definite integral, they will give the limit, the front limit, the first limit. It is then it is b from here to here. Now what we are getting from this means we will get an area under the curve. Okay, the definite integral is nothing but area under the curve. This is x is equal to a, then this is x is equal to b. This is a function f of x. Okay, the x-axis. So that means area enclosed by curve, the ordinates x is equal to a, x is equal to b, and the x-axis. Yes, we get the curve while integrate any function. But for the definite integral, between the limit, the curve covering some area, the bounded region, its area we are finding. That's all, children. So this is what a definite integral. Okay, yeah. So we can say this as area under the curve also. Okay, yeah, we need to find this area. To get this particular area, children, what we can do is integral a to b f of x dx is nothing but it is f of x, what we get to know, but there won't be the integral constant because it will be a single value. Area is nothing but what? Single value. Okay, it won't change at all. So now this is the upper limit, this is the lower limit. Okay, it is upper limit. Okay, upper limit and a lower limit. Now here by the fundamental theorem of integral calculus, we can say that it is f of b minus f of a. We can represent this as a limit of sum. How it is? See children, I draw the diagram. This is a curve f of x. Just to take this is nothing but it's not x1, x2, x3, etc. It goes. Okay, then it is xn. Now what you can observe is here like this. Children, here we can have the gap between. Now see, this is the entire area between a and b this f of x curve makes. We need to find that area as the sum of the rectangles. Okay, now see children, it is h, the gap between each. All are equal strips. Okay, h only, this h only, like this we are having. Okay, yeah. Now if I say this is a, means this is nothing but f of a, then a plus h, it will be a plus h, so f of a plus h, then f of a plus 2h, f of a plus 3h, like that it goes. Now how many areas actually, how many gaps over here? There are nh gaps because h n times, because we don't know how many, so we write nh. It's nothing but b minus a, because from the end we subtract the initial. Therefore your h is nothing but b minus a by n. Okay, yes. When this h approaching to 0, what will happen? See this is how we are having. So this is h. When this h approaching 0 means it will become as the single strip. Okay, then when h approaching 0, obviously this n tends to infinity. Okay, yes. So now see children, I want to get this area. So what will I do? Now this is nothing but that area is nothing but from the entire all the rectangles I am taking, it is h into f of a plus h into f of a plus h plus h into f of a plus 2h plus etc. It goes here. It is the last. This is xn minus 1. So here we can say it is h into f of a plus n minus 1 into h. Okay, this area. Even we can take the second one, x1 to xn also we can choose. Okay, so I choose this one, x0 to xn minus 1 as the length of the rectangle. The breadth is always h only, it remains same. Okay children, so from this what we can write is h out. Now f of a plus f of a plus h plus etc. f of a plus n minus 1 into h. Okay, yeah, so this is actually the area. Here we need to give this as the limit. That means the limit h tends to 0 h into f of a plus f of a plus h plus f of a plus 2h etc. It goes plus f of a plus n minus 1 into h. Okay, so now this is nothing but the area integral a to b f of x dx, area under the curve. Okay children, so hope you all understood this, the limit of a sum. Okay, we are representing the definite integral as a limit of a sum. Okay, so but like this only we should suppose. Right, for this we need to remember some concepts. You know what are the things? Limit x tends to 0 e power x minus 1 by x is nothing but 1. Then sum of first n natural number 1 plus 2 plus etc. plus n is nothing but n into n plus 1 by 2. So if this is actually sum of n minus 1, that means sum of first n minus 1 natural number 1 plus 2 plus etc. plus n minus 1, it is n into n minus 1 by 2. Next, sum of the squares of n natural number. So that means 1 square, 2 square plus 3 square etc. n square is nothing but n into n plus 1 into 2n plus 1 by 6. So this actually same way for Sn minus 1, it is 1 square plus 2 square plus etc. plus n minus 1 whole square is n into n minus 1 into 2n minus 1 divided by 6. Then sum of the cube of first n natural number. So that means 1 cube plus 2 cube plus 3 cube plus etc. plus n cube. It is nothing but n into n plus 1 by 2 whole square. It is Sn minus 1, which means what? Sum of the cubes of first n minus 1 natural number. 1 cube plus 2 cube plus 3 cube plus etc. plus n minus 1 whole cube. It is n into n minus 1 by 2 whole square. Okay, next is geometric progression. So that is actually what? A plus AR plus AR square plus etc. plus AR power n minus 1. This formula also we should suppose remember, that is A into R power n minus 1 by R minus 1, or we can say A into 1 minus R power n by 1 minus R. It depends the given sum. Okay, so these are the ideas we should suppose remember, okay, to do the sum. We do one sum on this integral 0 to 2 x square plus 1 dx. Here we can take the lower limit a as 0, upper limit b as 2, then nh is nothing but b minus a, which is nothing but 2 minus 0, nh is nothing but 2. Okay, we got this one. Now the integral formula, we know that integral a to b f of x dx is nothing but limit h tends to 0 h into f of a plus f of a plus h plus etc. plus f of a plus n minus 1 into h. Okay, this is what. Now we will be finding one by one. What is f of a? Is nothing but f of 0. The function f of x over here is what? X square plus 1. So f of 0 is nothing but 1. Then f of 0 plus h, it is h only, it is h square plus 1. Then f of 2h, because 0 plus 2h, a is nothing but 0 here. Right, it is 2h whole square plus 1. This means we can write it as 4h square plus 1. Okay, then etc. we can take f of 0 plus n minus 1 into h. So n minus 1 into h is equal to n minus 1 into h whole square plus 1 is nothing but n minus 1 square h square plus 1. Children, this can be written as like this also, 2 square h square plus 1. Okay, that's all, children. So now integral 0 to 2 x square plus 1 dx is nothing but limit h tends to 0 h into, we can write from the beginning, 1 plus h square plus 1 plus 4h square plus 1 plus 2 square h square plus 1 plus etc. plus n minus 1 square h square plus 1. Okay, like this we can write. So now we can group them. Limit h tends to 0 h into, children, we can see 1 1 1 1 up to n times it is coming. Okay, up to n times, therefore we can say it is n into 1 first case. Then plus this h square plus 2 square h square plus etc. plus n minus 1 whole square h square. Like this we write. Okay, children, so this implies limit h tends to 0 h out. Now n keep we can take h square out. Now what will you write? 1 square 2 square plus etc. plus n minus 1 whole square. Children, just now I gave the formula, okay, for sum of the squares of n minus 1 natural number. So limit h tends to 0 h into this n plus h square. Here we can write n into n minus 1 into 2n minus 1 divided by 6. Okay, yeah. So now we can multiply this h inside, children. So limit h tends to 0. Now this nh plus here only h here. So this means here h cube into n minus 1 into 2n minus 1 divided by 6. Okay, children, see here limit h tends to 0 nh plus, here I have h cube. This is actually what? H cube. Here I can find 3n. I can multiply inside 1h to n, another h to n minus 1, and the last h with the 2n minus 1. Okay, like that I do. So that means nh, here nh minus h, then 2nh minus h divided by 6. Children, we know the value of nh we got to know in the beginning, 2 minus 0, that is 2. Since nh is equal to 2, that can be substituted over here. Before we apply the limit, it is 2 plus 2 bracket 2 minus h, then 2 2s are 4 minus h by 6. Okay, children, now we apply the limit h tends to 0. Now what will you get? 2 plus 2 into 2 minus 0, then 4 minus 0 divided by 6. 2 plus 2 into 2, 4, yeah, 6. Now it is actually 1 2 2 4 3. So therefore you are getting 2 plus 8 by 3. So 2 3s are 6, 6 plus 8, 14 by 3 square units. This is actually area of the curve. It is 0 to 2 x square plus 1 dx. Okay, children, so this actually we use the limit of a sum to get the area. So by using the second fundamental theorem of integral calculus also we can get it. That is actually a to b f of x dx is nothing but it is capital F of x, then the limit is a to b. Okay, this is f of b minus f of a. Okay, in that way if I do this, means 0 to 2 x square plus 1 dx is nothing but x cube by 3 plus x. Now the limit is 0 to 2, it is 2 cube, it is 8 by 3 plus this 2 plus minus it is 0 only. So therefore 14 by 3 square units. You may be asking, sir, directly we can integrate and then applying the limit by using the second fundamental theorem of integral calculus. Get the answer. No, why are we doing this much bigger method? Yeah, this limit of a sum, actually this is the initial one. You need to remember this one. This actually will be asked for 6 marks, children. Okay, the integral using a definite integral as the limit of sum will be asked for a 6 mark question. Okay, yeah. So hereafter we will be doing the sums using the second theorem, that is integral a to b f of x dx equal to f of x f of b minus f of a, upper limit minus lower limit. Okay, children, any doubt in this limit of sum, okay, you can ask through WhatsApp. Thank you, children.